Hello again, and welcome to the screencast for Investigation 4 from the Levers and Pulleys Science Kit. This is part B, Pulleys at Work. I didn't get to finish the last one, so I'm going to finish it right now. If you recall, we had just seen a video of me lifting a load 5 centimeters using the 4 pulley systems. After each lift, I also measured the distance that the effort moved in each pulley system. Now, if you were paying close attention, you would have noticed something really interesting with the distance that the effort moved and how it increased each time we used a different pulley system. But let's go back to the data. Do you notice what's happening to the distance that the effort is moved as the effort is reduced? You probably notice that as the effort is reduced, the distance that the effort moves increases. And here's the kicker. That distance is directly related to the number of ropes. So to figure out effort, you simply divide the load by the number of supporting ropes. And to figure out the distance that the effort moves, you multiply the distance that the load moves by the number of ropes. Now, do you see how this could be a disadvantage? While it gets easier as you increase the number of supporting ropes, you have to spread your effort over a greater distance and a greater amount of time. This is the disadvantage. Now, a good portion of my students have difficulty understanding the concept of disadvantage. There's a great response sheet titled Pulleys at Work. It's student sheet number 24 that assesses how well students understand what parts 1 and 2 cover. To answer the prompt well, students must know how to count the number of supporting ropes. They have to calculate the mass of the load, and they have to calculate the effort needed to lift the load. Not only that, but they must also understand that the effort will move a much greater distance than the load moves. Furthermore, they must explain that this longer distance that the effort moves is the disadvantage. It's really a lot for them to grasp. So what do you think? How many ropes are lifting this pulley system? Which rope sections are directly supporting the load? If you said 6, you are wrong. It's actually 5. The last rope on the right is not supporting the load at all. This is actually changing the direction of the effort. So the total mass will be 20 kilograms times 6. You would divide that total, which is 120 kilograms, divided by 5 ropes, which should give you 24 kilograms of effort needed to lift the load. And if you see the prompt, Belinda can lift only 1 crate at a time, so she could only lift 20 kilograms. So students have to take all that information about pulley systems, analyze the prompt, and write a good response to the prompt. Okay, let's move on to part 3, choosing your own investigation. Let me be honest, I seldom have time to do this part. I mean, it takes 4 to 6 sessions. But if you have time, I highly recommend that you do part 3 with your students. The format for part 3 is similar to a science fair project. Students are given some project ideas. They complete a project proposal sheet, conduct their investigations, create some form of presentation, posters possibly, and present the findings to the class. Like I said, I highly recommend it, but it's really understandable if there's no time. And again, it also has presentation guidelines. This could be used as a rubric. Like I said, I seldom have time for this project, for that particular part, but hopefully you will when you do this unit in your class. Well, that's it for the Levers and Pulleys kit. Personally, it's one of my personal favorites. I hope these screencasts are helpful, and thanks for watching. By the way, were you able to identify all the farewell movie quotes? If you listen carefully, I ended each screencast with a quote from a movie. You have no idea what I'm talking about, do you? Well, see on my screencast to find out which quotes I had used previously. And remember, there are many more screencasts available, not just by me, but by other science specialists or teachers in the Boston Public Schools. Until next time, live long and prosper.